and just hit got it, you know. And now I'm gonna sort of just scroll back to the top here, and let's see what we got. See if there's something here that kind of looked hard.
I said, just packages. I feel like it'd be pretty cool. And interfaces and packages, I think it'd be a good review if you could kind of go over that.
Absolutely, absolutely. Let's do that. So what I'll do here, since there's nobody else on the online right now, for no particular reason, I guess, is I'll just go through maybe packages and nested reference data types. Would that be of help?
Yeah, yeah. I read the textbook on it, but it wasn't. I feel like if you explain it again, it'd be really helpful.
I'm very happy to do that. So let me sort of just try and get my my PowerPoint going. I can see it wanting to start up. God, that's slow. You know what I think I'll do, just to sort of speed things along, is just leave it the way it is. Whatever. I mean, what difference does it make? So what we'll do here is, okay. So in the world of reference data types, we got two kinds of reference data types. We got the classes and we got the interfaces. But there's a way to organize these into a separate namespace. That's the packages. And when we want to gain access to that namespace, you do an import. And if you import something like java.awt.list, well, then you can use the term list. And then if you do that, the name collides with the collections list. In other words, you're never sure which list you're using if all you do is use the term list, and you've imported collections.list and java.awt.list. And those two lists are totally different, but they have identical names when it comes down to the class. The only thing that disambiguates them is the class name, the package name rather. So java.awt.list is a fully qualified class name that includes the package prefix. You see what I mean? But collections.list, which is part of the collections, class, collections package, is it's got an identical name, but has totally different behavior, because one is meant lists for graphic user interfaces, and the other one is meant for a list for generic collections with no graphic user interface at all. So if you told me, oh, I got a package called, I don't know, annoying people, and one of the classes is called professors, and you got another class called smart people, and one of the classes is called professors. How do you know when you make a new instance of professors whether you're getting the annoying professors or the smart professors? They both have the same name, professors. So the only way to disambiguate is to say something like smart.professors versus annoying.professors. And you can see how those are totally different ways to organize the professor's class. Am I making any sense?
Yeah, kind of, yeah.
All right. So when you put in a package, you're isolating the namespace. But let me show you how that works. I think it's educational. And so what I'll do here is I will demonstrate for you what actually happens in the code. So what's actually happening is the output of the compiler goes into a directory called out. And now every single sort of package can have sub-packages and can have classes inside the package. So for example, if you were to go into tools, you find that there's all these different sorts of things like main.class. Now that main class is going to be completely different than some other main class. And if you said find dot pipe into a grep on main dot class, well, there's a bunch of main dot classes. I mean, there's one over here, there's one over there, there's one over here, there's one over there. How do I know which one I'm using? The only way to know which main class I'm using is by using the fully qualified path name, right? Video.jsnap.main.class is a totally different class than, let's say, video new quant main.class or addressbook main.class, right? You see what I mean? They're all different. And so they all have different package names, and the packages are really just names of folders. Tanya, I'm sort of just reviewing packages right now, if that's all right. Can you hear me okay?
Yeah, sounds good to me, Doug.
Okay, so we're basically just saying, you know, when you define a package, what you're really doing is you're defining a folder where your classes are going to go. And so when you have two classes with identical names and they're in different folders, like this one's JMF AVI demo versus JMF TSCC demo, those are different classes. It's clear they're in different folders. They have identical names, main.class. And if you import video.monty.jmf AVI and make a new instance of main, it'll make that instance unless you've imported video.monty.jmf TSCC demo, in which case the two names conflict. And you have to then proceed to disambiguate. That's a big problem. If I locate list.class, it's all over the place. Everybody's got a list.class. I mean, there's like a ton of these things. And so it's a sorted list, a track list, all kinds of lists. And plus some of the lists even have the same name. So it's a tough problem. And so that's why we are trying to organize the namespace with the packages. So packages are basically just creating folders for bytecodes. And the bytecodes go into a file that has a .class suffix. So check it out. If I said Emacs tail.class, that's the bytecodes. This is the output of a compiler. Now, what I can do with, the output of a compiler is I could try and decompile it if I have a Java disassembler like JAD. So then if I said something like, gee, I wonder what's in that tail.class. So I say JAD tail.class, right? Now I can look and I could say type tail.jad, pipe it into more and see what's in there. I thought it said it was generating it. Oh, there it is. Emacs tail. Oh, type is not found, right? Because you know why? Type is that's a Windows command. Stupid me. Okay. So then here's what the decompiled Java disassembler did. It took the bytecodes in and tried to reconstruct the original source. So if a Java compiler makes bytecodes, the Java disassembler reassembles from bytecodes the original source code. How's that grab you? Oh, and by the way, if you go to the top, you can see that it seems to have avoided the package name here for some reason. And if you look, you can see there is no package name. It's in the default package. So it's just at the root of the J4P code. So that's that. So that ought to give you a better feeling for what's going on under the hood, which is kind of interesting, really, because that basically is the part that they don't necessarily tell you when you're, sort of taking a first course in, here's tail, and that's what's really in it. They don't really tell you this when you are, how do you call it, taking a first course in Java. They don't go in under the hood to let you know about this stuff. And I think it's more educational than to simply, give you the PowerPoint death march where I just read through the damn slides, because that doesn't really help very much. But it does show you why when they say that the namespace is isolated by a package name, what they're really doing is they're using a directory to group the the byte codes, the class files together. And that's why package names are directed acyclic graphs, because trees are directed acyclic graphs. So when you go into, let's see if we can find some, yeah. So here's the address book ADDBK package, in which there is the J address book package, in which there is the main.class. So now when you go back to J address book, which you can see, here's the ADDBK package with the J address book package with the main.class. And when you look at it, you can see this is what I wrote for the package name. And when you go to the top, you can actually see that's the package name that was selected. Is it making any sense now?
Yeah, it's making a lot better sense. It just packages just mean it's just like folders that has other stuff like.
Exactly. That's all it is. It's just folders. And the folders are grouping together the classes so that you don't have to have a problem with conflicting file names, because every class that's output goes into a file. And if two file names are the same, then the files will overwrite one another. So that's why that is the way it is. And it is it's a bit of a problem, because sometimes people have issues that are the moral equivalent of DLL hell, where you have importing packages where they change the behavior because everybody's got the same name. So and this is a great way to introduce a basic problem in packages. Here's a package, chapter 11. Here's what we're going to do. Here's a list. Which list is that? Is it the Java util list? Well, let's see. When we did the import, we imported Java awt.star. Well, what does that mean? Well, what does it mean? It means that this is not the Java util list. This is a different list. Let's see what list that is. So you go and you do the look and you say, hey, wait a minute. That list is the AWT list, not the same list. You see what I mean? So this list doesn't work like that list, because they are two different lists. This one's from the collections class, and this one is from the AWT. And yet you can't tell. Right now, what if I said to you, let's import Java awt.list. Right? And now what we'll do is we'll go down and over here, and what we'll say is list. Should we import Java util list? Let's do that too, just to be clear. This is a really bad idea, okay? Java.util. And now look at that. He says I can put in a list. So now we're going to import this list. Now what's happened? He's gotten very upset with me because we have a conflict. Java AWT list is already defined in a single type import. So he doesn't know what to do. Now you got a list and he doesn't know which list this is, because they both have the name list. This is not good. You see what I mean? So one way to approach it is you import java.awt list, and then you can use the word list. But then when you want to go to use the Java util list, you got to use a fully qualified path name so that you don't get the wrong list. Because when you click on this list, you're in a totally different place. You're in an interface which was designed for collections. So that's why you got to kind of I don't know, the package thing is like, you got to be careful. Because when your packages come in and you start importing things where the names are conflicting, the compiler will not compile. It's a compilation error, and that's the best. You really want a compilation error here because it forces you to disambiguate, because otherwise you're going to get weirdo behavior and you won't know why. And that's a runtime bug instead of a compile time bug. I'll take a compile time bug over a runtime bug any day, because I can fix a compile time bug, because the compiler will go to the line number, it'll say fix this, and it'll tell you, hey, you've already imported list. You better not import the same name twice and put it in the same namespace, because you're not going to know which list you're running. So here's where I come in and I say, oh yeah, we're going to import, AWT list and a util list. And then it says new list. What is this? Which list is that? No. So that's why it's a compiler error. Does that make sense?
Yeah.
So this is an ambiguous class name conflict. This is something that has to be resolved either with fully qualified names like Java AWT list, knowing full well that is not the same class as Java util list. And so I could use a unique identifier, but then I'd have to go back and tell everybody to rewrite their libraries. And I can't do that. And besides which, I didn't write the Java AWT list, and I didn't write the Java util list. These are the things that were given to me as a part of the packages that were assembled by Sun and then later maintained by Oracle. So, Oracle bought Sun, and so they got Java as a result. So when I sit down and I group my references in a package, I try to do it so that I can have an interface that I document well. And then underneath, I try and, put in all the implementation crap, but I make it private. And then the only thing I want is a simple interface to the entire system. That's your best practices. And so typically I'll create some sort of a package that uniquely identifies me, right? So this is my top level domain, com, and then my domain, .java, and now here comes feudal. Now I don't actually do that. That would be best practice, but I don't actually do that. You can find feudals and the feudal file utility, but it's not in a package named like that. You can't declare the visibility of a package. Packages are always public. They're always public. So what that means is that they're just they're directories, and everybody can see the directories, and there's no hiding them. Sometimes with a disassembler, you want to try and protect your intellectual property, right? So you make it so that you scramble everything into a kind of soup. They call it Campbell. And Campbell will go in and it'll scramble all identifiers inside of of the bytecodes. But the packages it cannot scramble, because they are going to enable you to determine how to organize your bytecode files. All the classes are held in public packages. And so you've probably seen the different visibility modifiers: public, protected, the default where you don't, say anything, and then private. When it's default and you don't define it, then it's only package access. Nobody can import it. And when it's public, everybody can import it, but that means you probably ought to document it and make sure it's probably well tested. When it's private, those are the mechanisms that you maintain that nobody else has to know about. The only thing they need to know is sort of the interface to your system. That's what you make public when you're trying to publish some sort of framework. So here's an interesting point, right? You can have what you call read-only variables, right? When you say you've got a public getter, that's what you call an accessor. People can get the name, but nobody can write the name. Nobody can change the name, because even though customer is public, the member variable name is private, so you can't change it. Whoops. So I need public stuff because there's things that I'm going to publish that others will use, like the value of pi. I don't want them to change it, so I'll make it final. And they'll be able to go into math.pi and gain access to the value. And presumably they won't change it because you don't want people to go in there and change pi. Moreover, you may like to have a whole series of static methods, like in the math class, you'll have all your trig functions, and they're going to return double precision numbers. And the trig functions will be defined so that you can just say math.sign and you don't have to make a new instance. And in fact, you will not be able to make a new instance because the constructor will be private and you won't be able to subclass it because the class will be final. But every one of the functions inside of the math class will be public and static so that you can invoke sine and cosine and that sort of thing without having to worry about making an instance. So then comes this other level of visibility called protected. And protected means you're a class, a class author or a subclass author. So then if you're going to subclass my class and you're going to deal with the protected stuff, that's got to mean that you know what you're doing. You're doing the maintenance, you're going to maintain this code. You can operate outside the package, but only the protected stuff can be changed. And if you're not a class author or a subclass author, you don't know what you're doing, and we don't want you to mess with it. That's the policy. So that's what protected is for. I don't see it used often enough. In fact, I hardly see it used at all. Hey, Selena. So, Selena, can you hear me okay?
Hi, yes, I can.
Cool. So we're just going through packages right now because there was some issues with the packages and people wanted a review. So I was just kind of going through it. I don't know if you need it or not. But if there's anything in specific from homework 2 that people want to see or hear about, happy enough to go through it. And I'm recording this. So you've got, let's see now, public, private, protected, and then default. And if it's default visibility, you're not going to have access to it outside the package, and you may not even be able to subclass as a result. So I don't hardly ever see protected. I don't know why. I don't think people use it very much or use it enough. So here's another example of a read-only variable. I got the interest rate. You can't change it, right? It's private, but you can get it, right? Using the accessor. So when you make a new instance of taxes, you'll be able to get the interest rate. Then when Alan Greenspan comes along and changes the interest rate, well, that's done by this variable in here. So he'll call the Greenspan maneuver, increase the interest rate by a percentage point, and you'll be able to get the new interest rate, which will be perhaps 4% instead of 3%. I think we'll call it, we probably ought to change it now. It's the Jerome Powell maneuver. You could tell who was the Fed chair when I wrote this. We were like two Fed chairs before, right? Because it was Bernanke before Powell. So here's one with a setter where you set the interest rate. This is called a mutator. This is when you get the interest rate, they call it an accessor. And so that's the, the thing that lets you make it a write-only variable, right? That's very interesting, right? Here we can write the variable, but there's no accessor for us to read it. So people who make a new instance of taxes can change the interest rate by setting it, but they can't know what the interest rate is unless they're the ones who set it. So private is the kind of thing that you don't have to document very well, or if you're going to document it, you document it for your internal use. The public stuff must be documented and supported and stable. So that's when you build the interface and document it with Java doc and then tell everybody about it. So here's a nice interface, the interface to a car. getting the speed, getting your odometer, getting the gas. You know, these are not variables that you can write directly. If you want to change the speed, maybe you set acceleration, and maybe you want to set the steering wheel angle. But if you want to get the odometer, you don't get to, you're not able to set the odometer externally to the car. That's something the car does as part of its normal operation. And so with default, we don't do anything. This is, you know, the default visibility. But if you're trying to encapsulate complexity with private things, it's really good if you can have stuff declared private. So I got a lot of stuff declared private. If you look here at the Java code, right, you can kind of see some stuff which is being declared as public and some stuff which is being declared as private. So let's take a look. The print method just says, hi, Fred. Let's see now. Check out this package name. Book examples, chapter 11, packages, wilma.foo, right? So that is giving us the foo class from Wilma, not the foo class from Fred. So we know if we're in Fred or Wilma, right? When I make a new instance of the book example W and then print W, it's going to go to Wilma and say, hi, Wilma. I don't know if you have ever watched the Flintstones, but nobody says Fred. They say, Fred, where's Fred and Barney? Nobody says Wilma. They say, well, where's Wilma and Betty? So they're always coupled together somehow in the same sentence when you're watching the Flintstones. I don't know if you guys watch the Flintstones. So it's clear when you're trying to use the packages that when you have conflicting names like foo, it's not clear which foo you're running. So here's foo with an F and that printed out Fred. Here's foo with a W, that printed out Wilma. So it's clear we needed fully qualified package names. And when I go to the definition here, you'll see it says, hi, Wilma. It's a totally different class, totally different implementation, same identical name, except that it resides in the Wilma package. So this is one of those things where it's really important to understand the packages because they contain all of the important support classes which you're going to need for things like network programming. And that's a key element here. So when you want to import java.net.star and you're after things like a server socket or a socket or an internet address, you know, you're gaining access to things which are in the java.net package. And that's kind of important. And it's good to know how that stuff is working. So here we have some class which is extending a class that's not in the SOP package. And so this share me class presumably is A, not final, and B, public, and or at least protected. And so you can proceed to do that from outside the package. Otherwise, you wouldn't be able to. Let's take a look at an example where we have somebody who prevents you from doing anything. What we'll do is we'll go to the math class. Now, in the math class, you can see it's final. That means you can't subclass it. You can see the constructor is private. That means you can't make a new instance of it. That's deliberate. Why? Because if you said to me, I don't like the way the math class works because it uses radians and I don't like radians, I like degrees, right? That'd be a disaster for me because when I input a double and expect a double to come out, the compiler will say, it's fine. The compiler doesn't know that the double is a degrees or a radians. The compiler doesn't care. The only thing that's going to happen is runtime errors all over the place. It's going to give me incorrect results because it's expecting radians, and I'll be feeding it degrees, and somebody else will be feeding it radians. So in this case, you really don't want somebody overriding how sine works or how cosine works. And if you go to these methods in IntelliJ and you type in moth B, it will proceed to take you to the implementation. And if the implementation is a native, then what that means is somebody's calling a C subroutine library, and you don't have the source code for that here, it's somewhere else. So that's what the moth B does. So that's my shtick on packages. That's probably more than you needed to know, but at least it gives you some sort of an idea. Does that help?
Yeah, that was pretty helpful.
Okay, good. So we had a homework 2 coming in. We had some multiple inheritance. Let's see. I think, does anybody have any questions or anything they'd like to see more detail about for homework 2? Everybody's good? Because I got what I did here.
Professor, I have a
Yes.
question. Going to byte say SA with the brackets I. Can you explain that a little more? Because I was trying to do it
Sure.
and I got it wrong the first time, and I guessed the second, and luckily I got it right. But I don't know, how would you go about that question?
All right, so this was in homework 2.
Yeah.
Let's take a look. You happen to know what number it was?
I think it was
Um,
17 or 18.
it was one of the multiple choice questions.
17? This one maybe?
Yes, I think that one, or I think it's the next one.
This
Yeah,
one?
the next one. Yeah,
All right, so what does
Like-
the following do?
like
Um,
it's both 17 and 18, but I just want to know what the difference that little bit of code does.
Sure. So in C, C++, and Java, and perhaps a few others, the arrow is a right shift. The 8 is the number of bits you want to shift. So what this is doing is it's shifting SA of I, which is probably, I don't know, an int, over to the right by 8 bits. Then it's doing a bitwise and. And so what that does, this is different than and percent, which is a logical and between two Booleans. This and works between two scalars and not, two, I'll call it fixed point scalars. So that has to be bytes, those are 8, short, those are 16, int, those are 32, or long, or I think you can even get it to work with char, which is 16. And then 0xff takes the least significant 8 bits and isolates them, making everything else 0. So that's a bitwise and with ff. So it extracts the most significant bits, 8 bits, by shifting them over 8 and then isolating them with the mask. So not to put too fine a point on it, if you were to go into the operations under ops and you look at the shift utilities, you can find a bunch of these that are being given to you. But what we'll do is let's try one just out of curiosity. I'm going to try and formulate a PSVM. Oh, there's already a main method in here. Oh, let's call that main 2. So now we got 2 main bits.
So if those were all bits that were all ones and then you use that command, would that just turn it all to zeros?
Yes, if it was all ones and you ANDed it with one, it would stay one because 1 and 1 is 1. So let's see if I can't do this. I'm going to make let's see now, integer dot toString of 255 in base. Let's try base 2. So let's see if I can get that to work. I think that'll work. I can go base up to 36, although ideally he should give me up to base 64. And there it is. So let's check it out. 1, 2, 3, 4, 5, 6, 7. So that's 8 bits. That's cool. All right. So now let's take this right in through here and let's refactor it by introducing a variable. We'll call it X. That's good. I like X. Now in fact, what I ought to be doing is I'll introduce this as a variable. Refactor, introduce variable, and we'll call it I. Okay. So now I printed it out as a binary number. And what I'll do is I'll also make a new variable, J, and I'll set it equal to I, but I'm going to shift it over by 4 bits. And then I'm going to AND it with 0xFF. Right. So now what we'll do here is we'll extract this to a, this is called refactoring, by the way. We'll extract it to a method called print in binary. Print in binary. And now we'll print I, and then what we'll do is we'll print in binary J. So what that should do is it should give us, instead of 8 bits, it should give us only 4 bits. So let's have a look and see what happens. So we'll hit run, and I don't know if you're familiar with refactoring, but I don't like to have duplicate code. So I extract to a separate function, and then I can reuse the function without having to duplicate the code, because that's what they call a bad smell. And so here you can see what happened. We shifted it over 4 bits and did it with FF and got the least significant 4 bits isolated. Now, had we not done the FF, it still would have worked okay. Still would have worked okay. So maybe I can show that as well, just to make it clear. See, a lot of times what happens is people are using masks in network programming because they're trying to do something like an Ethernet interface, right? So when you go to system preferences on a Mac, for example, and you look at your network setup, you'll see that there's a mask that's used for a subnet. So here's the subnet mask, 255.255.255. And in fact, what that is FFFFFF. And then he says he only wants to deal with the 255 different possible devices that are in the subnet 192.168.1. And so you can now organize your devices underneath that IP address right in through here. That's going to come through, and everything else is going to be unique with respect to the least significant 8 bits. So that's all going to get masked. So not to put too fine a point on it, if I go to Etsy, on my system, it looks just like Unix because it's a Mac. And then I say more on hosts, you can see what I've done. I allowed my dynamic host control protocol range to go between 0 and 50 within my router so that when I plug things in, they can be automatically assigned. And then anything above that, I typically assign by hand. So I put in my different devices, and you can see they all get manually assigned IP addresses because I want to know where my laser jet is, so that if I'm interested in pinging the laser jet, it comes right back to me. And if I want to telnet into the laser jet, I can say hi to the laser jet, and then I can say something like, let's deal with the laser jet and let's configure it and that sort of thing. I'm going to get out of this before it drives me nuts. Sorry. So you can see when you have a lot of devices, it's really good if you give them names that you can remember, you see. So having an IP address is good, it's fine. But if you really wanted to gain access to your devices as a network administrator, and that's kind of important, right? Because you're probably going to have a bunch of devices in your subnet. If I go to my LaserJet, oh, really? There it is. So now I've got access directly to what is also known as 192.168.1.122, my local HP LaserJet. And it says I don't have any ink in my cartridge, which I happen to know. I only have 106 pages remaining, but I elected to leave it like that because out of ink is typical for these things. So that's one of the reasons why I emphasize things like figuring out the mask, because it has a role in network programming and a role in network administration. So here we go. Now we can see this is the classic digital design example, dead, right? And we solved this problem of converting it into decimal, right, from hexadecimal by using, does anybody remember digital design? You guys took it with me, right? Because I'm the only guy teaching it.
We took it with you.
Yeah, I think so. So, A is 10, right? E is like 14, D is like 13. And so it's D times 16 to the 0 plus A times 16 to the 1 plus E, which is 14 times 16 to the 0, 1, 2 plus D, which is 14, I guess. No, 13 times D. D is 13 times 16 to the 0, 1, 2, 3. So I don't know if you guys remember, that's positional notation. So with positional notation, and I should get a simpler example, but you can basically convert by hand into base 10. Now, of course, if you put it in as a literal in hexadecimal, the computer automatically has it in binary. And of course, when you print it, it'll print in base 10 unless you tell it not to. So if I said something like this, and you can certainly do this as an exercise, it's kind of a fun thing to do. Let's just do it because it's cool. What we'll do is we'll say something like this. Integer y is equal to 0x DEAD, semicolon, and then we'll say something like string. I'm probably doing this in the wrong place, right? I don't want to do this in this subroutine here. Let's bring this back over to here. We'll call this main 3. We'll make another main PSVM, enter, types it for you. That's kind of neat. Paste. And so now what we'll do is we'll make a string x, which is equal to integer dot toString. And now what we'll do is we'll take y and we'll set it equal to, let's make it base 10. Well, it's already base 10, isn't it? We have to, well, we'll make it base 16 then and print it out and see how it looks. S out, enter, X. And so that should give us a an opportunity to see DEAD. It'll be in lowercase. Yep, and there it is. Cool, right? So that's exactly the sort of thing that you could say, well, now let's see what happens if you take it and you say, and 0x FF. What will that give us? Anybody know? It just gives us the least significant 8 bits, AD. So that's how that works. Now, if I took this and I shifted it over by 8 bits and then ANDed it, it should just give us DE. Makes you kind of wonder why it's so slow. I mean, this is a very simple program, but there it is, DE. Maybe because it's recording. So what do you think, guys? Is it clear? I don't know if I answered your question, but that's kind of where this is coming from. And this is an inclusive OR. So I got bitwise and I got inclusive OR. What else did you have a question about? Anything in particular? I don't know I think I might have beat a dead horse with that last example. So this is a left shift instead of a right shift. And if you're left shifting by 1 bit, then it's times 2. But if you're left shifting by 2 bits, then it's times 4. Because 2 to the 2 is 4, right? So you also has the right shift equals, which is the same as I equals I, right shift 3. So it takes I, shifts it to the right 3 bits, and then sets I so that it overwrites it. And this over here is 2's complement. Complement and increment the accumulator gives you a negative number. So if you remember the 2's complement from digital design, that's what this is doing. And that is the internal representation for C, C++, C#, and Java. Everybody, all the computers, all the modern languages are using 2's complement for the, I'll call it fixed point scalar data types. Floating point, it's a little bit more complicated because there's mantises and that sort of thing. Any other questions? Homework 2. Kind of beat a dead horse with that one, I think. I hope I didn't. I can't see you guys, so I don't know if this is too much. Was that too much?
Thought it was fine.
Okay, good. So the next thing I got available for you, and this is all in the sense of a review, right? This is a review of Java for people who might not have seen it lately. So the next one is on arrays and collection classes. And I think if I hit begin, I don't want to show you the answers. I just wanted to show you the questions. So if you have a list and you want to sort the list, you have to figure out how to compare it. So if I told you I got a list of fruits and it's apples and oranges, you say, well, okay, but how do I sort apples and oranges? And the answer is, well, maybe you'd like to sort them by calories. So then you have a comparator that says get calories, and if 1 calorie is less than the other, it's -1. If it's greater, it's +1. And if it's equal, it's 0. And you could say, well, maybe I don't like calories. Maybe I like vitamin C. And so then you can compare them based on vitamin C or carbohydrates, if you like, or whatever you want. So at some level, if you're comparing apples and oranges, you have to tell the computer how the comparison works. So that's what a comparator does. And you can feed the comparator into a sort facility, either when you make a new instance of a collection or when you invoke the sort method directly, let's say in a vector. So vectors, are better than arrays if you're dealing with raw array data types, because once you make a new instance of an array, the array length is fixed. You can't increase the length of the array and you cannot decrease the length of an array. In comparison, array lists or vectors can have adjustable lengths, and they can be grown and they can be, what's the opposite? Grown, shrunk? They can be shrunken. They can be reduced in size. I'm not sure what the right term is. Somebody tell me. They're not shrunken because that doesn't sound right, but they can be reduced in size, in length. So you can remove elements in the list and make it shorter. Okay, I got it now. They can be made longer or they could be made shorter. That's better. They're not going to be shrunken because that doesn't sound good. They're squozing down, squozing. So yeah, English. I think I could say words. So interface visibility can be protected. That's good. You probably know that Java has multiple inheritance of specification with interfaces, but no multiple inheritance of implementation, right? Why is that? Well, because if you had multiple inheritance of implementation, then if you put one class in front of another in the list, you would get different behavior if you change the order. Because what happens when you have, let's say you define a class called human, and then you decide you want it to be something you can draw. So now you make another class called drawable. Now you have a class called drawable human, which imports, which extends drawable and human. It changes its behavior depending upon whether the human is first or the drawable class is first. That's called topological sorting for disambiguating how you shadow methods with respect to one another. That turned out to be a fruitful source of bugs. So as a result, Java decided to dispense with multiple inheritance of implementations and left you with multiple inheritance of specifications. And that's how Java achieves polymorphism. So that's a pretty important point. We define a language. It's very interesting. We define a language as much by what we leave out in terms of features as what we put in. So if you're putting in a whole pile of features like PL1 has a disease where it was designed by committee and everybody threw in every single stinking feature they could think of. VHDL came out that way too, designed by committee. Once you start doing stuff like that, your language is so big that you learn something new every time you open the book. And nobody can know all the language features. And Java kind of suffered from that when Oracle took it over and started to extend the language in ways that made it sort of exotic. And I kind of felt like, they were just grabbing onto every single computer science feature they could find. And some of them are kind of obnoxious. Instance of, you guys have seen this before, right? So that determines if a class is an instance of list. So if you said, is it an instance of a java.awt list, that would come out as false. So now you can determine which kind of list this is from. Here's the array list where you're adding elements. And this is the one where you can add elements and you can remove elements. And it's nice in a sense because array list will take references and can be expanded or it can be contracted. However, if you're trying to do something efficient, like make a two-dimensional array of pixels for an image, this is absolutely not the right thing. And I've heard people on YouTube say, oh, array lists are fast enough and you don't have to worry about it and everybody should use nothing but array lists. Well, that's weapon grades baloney. Because if what you're trying to do is make a 1 megapixel image, the last thing you want is an array list, because it's going to run 6 times slower until it finally fails because it ran out of memory. Because each one of those references is a 32-bit address, and it's just an address that points to another 32 bits. It doesn't make any sense. So if what you're trying to do is image processing or signal processing, that's absolutely the wrong thing to use. But on the other hand, it's a very good data structure. It'll let you do all kinds of interesting things with data structures, and it might be the right thing for your job. But, you know, AWT list is not the same, that's for sure. Different class, different packages. This one is meant so that you can have a displayable list, and this one is just meant as a data structure. Maps will take items and relate them to keys. Typically, you want to have some sort of mechanism in place, like hash keys, that allow you to access elements quickly. And you can have maps so that they are sorted, so that when you add elements to the map, it knows how to sort them, because remember comparator, there's a implementation of the comparator interface, which is passed into the sorted map when you create it, so that every time you add an element to the map, it becomes part of that sorted collection. And so collections are interfaces, and they require that you provide implementations for things like the size, whether or not it's empty, whether or not it contains another element. These are the abstractions which effectively are hidden from you. So when you're dealing with collections like maps and lists and that sort of thing, they all have different implementations. Moreover, when you're dealing with something like sort, the sort implementation is highly optimized. It came from Software Practices and Experiences, and that particular article was cited when you look at the sort method inside of the collections class for sorted lists. So that's a, somebody worked really hard to get you a decent way to do sorting, but you had to provide it with a comparator, an implementation of the comparator interface, or else the sort couldn't work. Sort needed to know how to compare things. It may already know how to compare something like strings, that's okay, but other things like apples and oranges, it doesn't know. Iterators are Java's way to get through long lists. So that's how you do next and continue to iterate through the list. Remove, of course, it's obvious. When there is another element to be had in the list, has next will come back as true. And now here's an example where you can do your iteration. So your iterator is coming in from some sort of a collection. Collections have iterators, and now you can keep doing an iteration, and you don't know what this collection is. Could it be a map? Could it be an array list? Could it be, I don't know, an ordered list? We don't know. We don't know. So this is an example of polymorphism, because it'll work with any collection. Here's a really nice compact way to go through a list with a for loop. And so here we are going into the instance of the book in the book list, and it'll go through each one in turn and print it. So that's actually much nicer than trying to write, I don't know, something that examines the length of an array and then creates an index that ranges from 0 to the array length and then prints every element in the array. That's typical for what you would do prior to the collections classes. Did they cover collections in any of the courses you guys took? Did you guys take a first course in Java and that's it? Somebody speak up.
Yeah,
Um,
I just took like a single class in Java. Like it was like an introduction class to Java.
Did they do collections classes in that class?
It's been a while, so I can't really remember. You could probably
Can't
ask like
remember.
someone else that took it recently. So
All right. Well,
Um,
yeah, Selena, go ahead.
Yeah, I was just gonna say they didn't really cover it much in depth from the class that I took last semester.
Wow. Okay. I'm reluctant to force you to go through the PowerPoint death march. I'm just kind of reviewing these questions so that you can have seen these things before. And if you've never seen anything like this before, yeah, maybe I should do the collections. I don't know. I have the PowerPoints. So if you've never seen this stuff before, you can kind of get a feeling for what's going on here. The array list is an implementer of the list. Vector is an implementer of the list. Stack is a subclass of vector. Let's see now. Iterators and list iterators are sort of interfaces off on the side. Collections consists of a whole bunch of utilities that manipulate the collection instances. So they'll give you a whole bunch of things that you can do. So a collection, we can see it comes in the form of an unordered set or a sorted set. And when you make a new instance of a sorted set, you're going to make a new instance and pass into the constructor a instance of the implementation of the comparator interface so that things can be sorted as you add things to the set. You want to have an idea about whether duplicates are going to be allowed in your set or not. And here's that map and the sorted map, which are, I guess, kind of obvious things. And here's what you do to make use of this stuff. You can get access to util collection, but you can also use util collections with the S. And that'll give you the algorithms for doing things like sort and binary search, copy, shuffle, reverse, min, max, that sort of thing. So that's sort of, I think that's generally useful. Here, when you look at an array, this array is immutable. So when I created this array, 1, 2, 3, 4, it had 4 elements starting at 0, 0, 1, 2, 3. And what it did was allocated that space to the array. You cannot reduce it in size, nor can you grow it in size. Then when you take the array and convert it to a list using the arrays as list invocation, you can then proceed to do a sort under collections.sort. Now it's going to sort based on alphabetic sorting. And then you can proceed to print out the list. And now here's the binary search, and you can search the list. And that's coming from the collections class. So now you're seeing collections being used, collections in action. And so it'll show you where Bob is in my collection after sorting. Then you can do things like shuffle and then print it out again. So here it is sorted. And you can kind of see maybe lowercase has less of a value than uppercase. And so that's a artifact of how they organize the letters. I think they remove one of the bits in ASCII in order to go from uppercase to lowercase. So this is an interface, collections and interface, and there are several implementations. So that's kind of cool. What can I say? This is the sort of thing that you might like to watch on your own with the video, but I'll just kind of thumb through it real quick. Because if I go through this, it's the PowerPoint death march. And I know there's a little something in the book you can read about this. And of course, there's plenty of good videos online. But any collection interface implementor is going to implement these methods. And oops, the iterator is just going to be one of those things that lets you go has next or is or just invoke next. And it'll get you through every element in the collection. And here are different things like queue, sorted set, set, and list, all available in collection. It's not clear to me how valuable it is for me to go through this sort of, I'll call it the PowerPoint death march. It seems like it might be better for us to do an example, but let me see if I can just quickly show you something or other in the code. So what I did here was I wanted an address book. My address book needed to have address records. And so an address record would be something that implements serializable and has comparable. Remember, comparable was something you needed to implement in order to be able to sort the addresses. So when I go to my address book, and here it is running, and I go to the top, I can guarantee that everything is sorted. And that's because each address record is part of the serializable and comparable interface. So with comparable, you can see the interface, and this is using templates. And now he's giving you an integer, which is going to be -1, +1, or 0 if they're the same. So for comparing address records, I have to have something in here that does a compare. So probably down in here somewhere, do a string compare on the name in the address record and ignore case. So I've decided I'm going to compare based only on the content and not on the case of the name. So that was my decision. And so I altered the way addresses would be compared, and I didn't care about the address because I don't want to sort on address. I'm only sorting on name. And I could have said, oh, let's sort on zip code, but I'm not doing that. That's a different, that's the other department. So that's a way to deal with it. Serializable allows us to take an instance of the record, put it into the address book database, and save the whole thing. So when you go to, I'll show you what happens here. It's kind of an interesting thing. When you go to my address book location, you see where it says address folder right in through here. These are gun-zipped versions of the serialized databases coded by date and time. So what I have is 2023-02, which would be February, 02, which would be today, and then it says 18:24 and 36 seconds, so that's going to be Navy time, 24-hour time. So if I were to go in and do a save, what you can see over in here is that it saved it to something that says 1002. And so presumably, there it is, 1002. So that's what serializable lets you do. It lets you take an instance of a class and save it directly to, or an instance of a database even, and save it directly to the disk or transmit it over the network, which is really important if you're trying to do parallel programming. So we're going to get back into this serializable thing a little bit later, because you're going to need it in order to be able to take instances and pass them across the net. And you can see the implementation is like nothing. There's nothing there. But what you're doing is you're taking all of the data and you're stashing it somewhere so it can be reconstituted. So that's what serializable does. And the other way you can deal with, serializing your data or saving your data is to make a data structure and tokenize it. And I do that too, using record delimiters and CSV files and that sort of thing. But if you really want to just kind of store your database someplace on a regular basis, serializable is the way to go. Here's another way to go. You can convert the whole thing to XML. So you can take a byte array output stream, run it into an XML encoder, and then do a write object. Because it's serializable, that will take this instance and make XML come out, which is really cool. So that's another thing you may want to put in the back of your mind, because what will happen is we'll be writing XML in a file and then decoding it. And so that comes up a little bit later. I think it's around, it's in the chapter 43 or 44, I forget now. So that's that's kind of an interesting idea, right? Because now when you look at the address record, there must be a place where these address records go. And you can mouse right on stuff and find usages, and you'll see that there are a number of places where address records are being used. Once you make up something like this, it has a kind of inertia associated with it, where it gets used a lot. And you find it in one place, and all of a sudden it comes. It's all over the place. It's sort of weird, right? I mean, you make a decision about how to design a piece of code, and then all of a sudden it impacts you for a long time, and it kind of sticks with you. So there's that. Let's go back to the PowerPoint. So collections, yeah. Have you ever heard of the singleton design pattern? Is that new to you? Any, Selena, have you heard of singleton?
I have not heard of it before.
Okay. So in the case of design patterns, what happens is people are looking to make sure there's one and only one instance of something. In order to do that, what you do is you make the constructor private, and you make it so that nobody else can make an instance of the class by making it final. And because the constructor is private and final, if you want to get the instance, what you do is you put in a getter where the instance is obtained once and only once. So let's try an example of this. We'll go into the, where shall we put this? Probably, let's just start it with a simple hello world. New Java class, we'll call it hello singleton. Okay. So here's an example of the singleton class. It's public, okay. I want to prevent other people from instancing it. So what I will do is I will make a private instance of singleton so that no one can instance it. And then what we'll do is if somebody wants the instance, we'll give them a private static hello singleton HS equals new hello singleton. And what we'll do to keep them from making new instances by subclassing is we'll make it final. Now, if you want to gain access to the only singleton class, you put in public static hello singleton get instance, and then return HS. And this guarantees that there will be one and only one singleton, because you can't subclass it, it's final. You can't instance it because the constructor is private. But you can tell that there has been an instance created over here. And by the way, you can gain access to it as a read-only instance from the getter get instance. So you can say hello singleton.get instance, and that will give you the instance, the only instance, which might be very, very useful if what you have is a pool of connections to a database. Then your instance can manage who gets those connections and how many are available. And that connection pool may be something that is something you don't really want to give out too many of, because when people are done, they should return the connection pool so that you can go and give it to somebody else. So this is this is called the singleton design pattern. Design patterns are just like design patterns for bridges. You might know trestle bridges and suspension bridges and cantilever bridges and cable stay bridges. They all have a basic sort of design behind them. Same thing for textbook designs for antennas. You might have dipole antennas or Yagi antennas or microwave antennas with dishes, all these different sorts of UHF antennas. These things are well understood designs. So we have the same thing for software engineering. And so this is a design pattern. And if you go to my papers, you can see that I have a series of journal reprints here. And if you look at the parametric singleton design pattern paper, I think this will open. Oh, there it goes. What you can see is that I will use a parameter to use singleton design and then choose exactly how many instances will be created. This is called UML, for Unified Markup Language. And so what this does is it lets you lock resources so that others will not have access to those resources. And you can do it for things like I did it here for a registry. It's interesting, right? Because what you're doing is you're making access to a consumed resource available in limited quantity. And so you can basically go and control access to it. And it's the moral equivalent of this. Suppose I went to the secretary and I said, I want a list of all the alumni. She'll say, yeah, what do you need it for? I say, well, I want to hit them all up for money. She'll say, well, wait a minute now. Let me check with the dean, right? She controls the list. She makes sure I have access. And the dean might come back and say, no, 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 no. We don't give out that list to Doug Lyon. Oh, no, 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 no. And then he'd be right in saying that, of course. But in some sense, you know, this is the sort of thing that you want to be able to control access to and decide whether or not these are things that you can give out. So there's a little article. When is a singleton not a singleton? And they talk about the singleton, simply singleton, Java world. And it's kind of an interesting idea, right? Singleton design patterns. This is back when I had hair, which is, I sort of remember having hair. So there's that. Let's see what else we got in here. I think we got to the end of this one. Now, you know, what I did was I set you guys up to do one homework per week. Each one is going to be due end of day on Wednesday. And so I've been busy releasing these things to you as quickly as I could so that you could gain access to them, and you get 2 stabs at it, and you're getting the higher of the 2 grades. The grading for this course, I don't know if we went through this, it's 1/3 midterm, 1/3 final, and 1/3 homework. So I wanted you guys to try and keep up. With the homework, I'm giving you 2 stabs at it, and you're getting the highest grade of the 2 stabs, and you're getting some feedback. So let me see if I can get this in here and just kind of give you the brief rundown. This homework 3, if I look at the options, should be due on the, I think it's the 8th is a week from now. Yeah, so there it is. So that's due on the 8th, and you're going to have after submission, you get feedback, and you get to see what you submitted. You get 2 stabs at it, I think. Let me just make sure. Yeah, you get number of attempts too, and you get some information about your feedback. Has the feedback been good for you guys? Have you been able to?
Yeah, they're pretty good.
Pretty good. I could make it easier. I could probably show correct answers. But that makes it a little too easy. Maybe I should let you guys think about it a little bit. So we'll do that. You get everything all at once. You take as long as you want. And then I also put in the Java thread. So at this point, when we're getting to the threads, and I think I'll save that thread discussion maybe for next time. But if you look, you'll see there's a paper for you to look at. There's some videos for you to look at. There's some reading, and I'm relating this directly to the reading in the Java for Programmers book, and we're getting right out to chapter 13. So that should give you a little heads up, and if you're going to go through and do the reading. This is a big one, though. It's 43 questions, and you get a little bit more than 100 points on that, and that'll be the next one up. So if you guys can get your reading done, that'd be good. I think I gave you enough PowerPoint torture for now. What do you think? You want to call it quits for the evening, or you want some more? You guys tell me.
I think this is okay.
This is good. Everybody all right with what we've done here so far?
Fine by me.
Okay, if you want me to do a little bit more, I will, but otherwise I think I'm going to call it quits. It sounds like there's a general consensus that we're done. All right, so I'm not going to torture you with any more
Professor, if I have any
Yes,
questions, I'll send you an email, but I'm okay.
Oh, good. Okay, then. All right. Well, have a good evening, everybody. I've recorded this so that you can watch it later if you like. And what I'll do is I'll post it to the where shall I post it? Oh, I know. I don't know if you've noticed, but there's a website for the course. And if you go into computer networks, you can see I've got a little list. Right. So what I'll do is I'll put it in. I'll put the link in that list so that you can always go back into here and click on one of the videos if there's something in particular that you'd like to learn. And you can see the chapter videos are all here.
Professor, I thought this course is called network programming.
Yeah, at the graduate level, I think they ended up calling it computer network programming. And at the undergraduate level, they called it computer networks. In fact, if you notice, these numbers that are here on my website are the old numbers. And I talked to several of my colleagues, including some that are not even in the School of Engineering, and they all still relate to everything with the old numbers. for whatever reason. I think we're very slow to change. So these videos are all here for you guys to look at if you want to. And of course, you've got your reading. So, so there's that. You know, one of the things about computer networks is there is a little bit of probability associated with it. And you'll see that in some of the homeworks that are coming up. So we'll have some queuing theory put in there as well. And I'm going to try and review some of the probability for you, just in case you guys are a little bit rusty with probability. So I'll do that. But that'll come in later because I think right now we're kind of getting a little bit burned out. So that's what I have for you for tonight. I understand it's going to be a little bit cold tomorrow, so stay warm.
To Professor. Thank you.
Thank you.
Thank you, Professor.
Thank you. Good night.